Hello everyone and welcome to this edition of Inside the Naval Postgraduate School. On the Pentagon Channel, I'm your host, Alan Richmond. Well, normally we come to you from the campus of the Naval Postgraduate School in Monterey, California, but as you often find the case, we're on the road, this time at the TNT exercise at Avon Park, Florida. And with me, our first guest of the show, under beautiful, hot, sunny skies, sorry for the shades, everybody, is NPS Professor Ray Bittner. Ray, welcome to the show and nice to be with you again on the road.
Thanks, Alan. Good to be back with the team and good to have you here in Avon Park, Florida with us again.
Now, we do this operation as a joint operation with SOCOM. How did that come about and how's the collaborative effort going with them?
Well, the collaborative effort with SOCOM began in about 2002, actually, with very small field experiments. We had a SOCOM student at the school working with a couple of professors, and they actually developed what today we would know as the rover system in the field. Basically, how do you bring video down so the soldier can tell what's going on around them instead of just the command post knowing what was going on around them. And that was very successful, and over the years, the Naval Postgraduate School and Special Operations Command have developed a very tight relationship, not just in experimentation, but also in academics. In fact, SOCOM's current commander, Admiral McRaven, was the first Special Operations Low Intensity Conflict student at the Naval Postgraduate School and actually helped start that program. His thesis is still pretty widely read too. He did a theory of special operations, or the theory, I should say, of special operations. So the Admiral's there at the helm at SOCOM, and the relationship with NPS is still going strong academically and out here in the experimentation venue. You know, we do 4 of these events a year, 50 to 60 experiments that are planned and conducted, and 500 to 800 people that are out every time. One of the most powerful things about these particular events is this is exploration and discovery, which is why NPS is such a natural partner for SOCOM. They're here to learn about things, not necessarily buy things. What they learn may help them think about what to buy down the road. But this is not an acquisition event. This is a learning event, and people are allowed to come out and try things that don't work, and they get feedback from the soldiers that help them make it work. We see companies collaborating out here. Right now Boeing is working with our vision, and they're sharing information, they're sharing products, all about helping the soldiers learn more. We have a couple NPS students running around out here as well that are doing work, a continuation of work that was started by 2 of our majors 2 years ago, focused on light attack and rapid air mobility platforms. We have a student running around looking at the different sensor packages that would go with these light, almost commercial off-the-shelf aircraft that can augment our special operations forces. So as usual, very dynamic, very active event, and a very tight marriage with SOCOM and NPS.
And the important thing always, and I always enjoy going on the road on these with you, is the fact that it's in direct support of the warfighter. And nobody seems to ever lose sight of that fact. We're here, it's not a showcase. It really is hard work to turn this technology back over to the frontline folks.
Absolutely, absolutely. We have success stories where technology is proposed out here, goes through the process, and winds up, on the shelf working with the warfighter. If you recall, a while back we had talked a little bit about a special SIGINT capable Scan Eagle aircraft, and I know the Inside NPS has done shows on the Scan Eagle and that aircraft and its capabilities. And Navy Special Warfare, one of the SOCOM's components, has the capability that was developed in 9 months, 3 TNTs, boom, out to the warfighter and ready to go. So we're very happy that happens both as citizens, and then of course the mission of the postgraduate school being to enhance the effectiveness of the warfighter. It's a very direct connection.
The other thing that you say many times out here is failure is an acceptable outcome. And I guess that really is the important thing of taking the technology and the collaborative efforts and pushing it to the limit so we get there in a hurry to get that product out to the folks.
Absolutely. You've got to try it, and you've got to be open and share information about your failures for us to be able to learn and move things forward fast. Environments in which companies or organizations want to hide their failures and hide their problems could be very dangerous if something slips through the system and winds up on the battlefield that's not fully vetted. Out here, companies know there's no penalty for them trying something and finding out it doesn't work. Soldiers can suggest things that they're not sure what the outcome's going to be. Exploration discovery is kind of why we use the term experiment when we talk about what we do out here.
And so overall, what's the most important takeaway for you in getting the TNT events put together? What do you come away? It must be really gratifying professionally and personally.
It is. Myself, my team, I have a couple of research associates that help me put these events on at the school, and then our students participate. And to be able to be engaged at this level of interaction and to know that there's a direct output that will help our warfighters on the battlefield is extremely gratifying, and I'm always delighted to be part of this.
Thanks very much.
Always a pleasure.
Well, at the Naval Postgraduate School, we're all about collaboration, and that's what we're going to talk about here at Avon Park with Ray Jackson, who is with CIRPAS. Tell us a little bit, Ray, about your role at NPS and CIRPAS, first of all.
Well, my role, Alan, is I'm the UAV program manager for CIRPAS. CIRPAS is a center under the Naval Postgraduate School. It stands for the Center for Interdisciplinary Remotely Piloted Aircraft Studies.
And tell us a little bit about what you're doing here at Avon Park. I know we're talking a lot about collaboration. How's it all going?
What we are doing here at Avon Park in supporting TNT and the USOCOM exercise, CIRPAS, NPS has just come under possession of 5 of the Sentry Block 30 aircraft. And to us, the Block 30 aircraft has a very large payload bay and will make for a great platform for testing different payloads on it. So we at NPS, we can now provide the aircraft. So if another DoD department or a commercial entity wants to prove out their payload, it's easy for them to integrate it into the CIRPAS, and we can provide for the flight services. That's basically what we do at CIRPAS NPS. We provide for flight services, and we provide for the equipment itself. Provide a turnkey operation, so if any other organization, they come to us, put their payload in it, they don't have to worry about the basics of flying a UAV.
Talk a little bit, if you would, Ray, about the importance of TNT. Of course, we're at Camp Roberts every once in a while, and here in Florida. The atmosphere lets us do what?
TNT is designed as a collaborative experiment. It's not designed as a convention or as a trade show. It's not a trade show, exactly. Right. Thank you. It's more for different industries and different DoD organizations to come out here and show, hey, this is what we're working on. Will be good for the war fighters. Everything we do basically is for the war fighters. Obviously, they're the important folks, and so they want to fast track certain technologies, and so they bring it here. USOCOM gets a good look at it. They bring their soldiers out to actually look at it and give their advice to it as well. If they think, yeah, you need to improve this, you need to improve that, or this is great except for that, they can give that information directly back to the contractor. And so the basic driving motive is to get that good technology into the hands of the warfighter as fast as possible.
And you have been involved in the CIRPAS program for how long with NPS?
I have been involved since 1998.
Okay, well, it's got to be really rewarding, as you say, because it directly impacts those guys on the front line.
Oh, absolutely. You know, I'm an old retired Army guy, and the fact that I can still work with troops is just a joy every minute.
Great. Well, thanks for letting us talk to you out here.
Thank you.
Well, we're talking now with Joe Shimmick with DRS. Joe, tell us a little bit about your role with the company and what DRS is all about here at TNT.
Sure. I'm the Director of Unmanned Systems for DRS Training Control Systems in Fort Walton Beach, and we're part of Defense Solutions. The organization in Fort Walton Beach, we design, manufacture, and test unmanned systems, both air and maritime systems. What we have here today at TNT is the Sentry unmanned aircraft system, and it's a Group 3 unmanned system capable of flying payloads up to 100 pounds. Typically we range up to 75 as a standard payload, 2.5 cubic feet of volume. So a wide open payload bay that's modular, easily reconfigured, 1,500 watts of power, gig-E connection as far as the payload, and a lot of bandwidth coming down to the ground. So it's a perfect platform to integrate payloads and swap out, easily, quickly reconfigurable. It was designed to be expeditionary and rapidly deployed.
Great. Well, continued success on your research.
Thank you very much.
All right, thanks. Well, stay with us. Coming up after the break, we'll talk about the weather and the role it plays with the military, right here on the Pentagon Channel. Well, all of us know that weather plays a very important role in our daily lives, but have you ever really thought about the impact it has on the military? Well, that's one of the experiments and testing we're doing here at Avon Park in Florida at the TNT. With me is a research professor from the Naval Postgraduate School, Peter Guest. Peter, how are you today?
Oh, doing fine. Wonderful weather out here.
It is. Well, speaking of weather, yeah, we had to put sunscreen on today. You know, weather is an important issue to all of us, but as I just mentioned, with regard to the military, I mean, you're out here participating in TNT. Tell us what your focus is.
Well, I'm doing several things out here, actually. three kind of projects. One thing I do is basically provide a service for the other experiments which are going on. I launch a weather balloon, which you'll see pictures of, and that measures the pressure, the temperature, and the humidity, and also winds throughout the atmosphere. And that's information that the flight operations, for example, are interested in, and to get what the winds are going to be like, whether their aircraft's going to be safely flown. I also provide a weather brief in the morning where I'll give the forecast for the day and for the next day so people can plan their experiments accordingly. And then the second thing that I do is I perform my own research. I'm not actually a trained forecaster, even though I do that here. I'm a physical meteorologist, so what that means is that I study physical processes in the atmosphere, such as radiation effects, turbulence near the ground, and some of the things that we don't normally think of when we think of weather, but that are very important for military applications. For example, the humidity structure in the atmosphere affects how well a radar will work, what the range of a radar will be like. Also, ranges of communication systems are affected by the atmosphere.
Walk us through a little bit in terms of we're watching you as you're assembling the weather balloon that you're going to launch. Give us through the steps. I know you have to start by calibrating and some other steps before it actually goes up in the atmosphere.
Yeah, it's pretty simple, really. You don't have to have a Ph.D. to figure it out, but first you take the Raven sign out of the package and you hook it up to a ground calibration machine, which will check to make sure that the temperature and the pressure and the humidity are what you think it is, and it will also communicate with the computer that we're using to collect the data. Then we'll attach that to a balloon, and sometimes, particularly over land, I'll also put a parachute on the balloon so that it will come down safely. And in the particular launch that we're going to see, I also put a slow leak using a plastic syringe. It's a method that my colleague Dick Lynn developed, and so you put a little leak in the syringe, and then you pull the plunger out, and the helium slowly leaks out, and then it goes. Once I launch the weather balloon, it will go up in the air, and then it will come back down again. So I'll actually kind of get two profiles of the atmosphere for the price of one, and that way we'll kind of see what kind of variability we'd expect, because there are changes in the atmosphere. The temperature does have variations, and by just launching once, we may not really be totally representative of what the sort of the average conditions are in the atmosphere. So
great. Well, Peter, we appreciate the information very much. Well, technology is an important part of TNT. That's why we're here, and we're talking with Miles Newlove about Ares, which is just behind us here. Miles, tell us a little bit about this unmanned vehicle.
The Ares was designed as a multi-mission UAS to carry multiple payloads, government and commercial payloads, that simultaneously could be flown. It's the one of a kind. There hasn't been anything out there that can match its performance. And it allows the warfighter to carry out, instead of just a single mission with a single payload, multiple payloads, so they can retask it on a single mission to carry out other eventualities that might occur on the battlefield.
How long can the vehicle stay in the air, and what's the speed and kind of weight of this vehicle? Okay,
the Ares is 8+ hours in endurance, and the payload is 120 pounds plus. The speed is, average cruise speed for it is about 80 to 110 knots. So it's quite fast. It's a lot faster than the similar sized UAVs out there.
And how's the testing been going so far? What are you hoping to achieve today?
Today we're actually implementing a new PED management software on the ground side. We're streaming full HD video on multiple different wavelengths down through the FLIR 380 HD and other Harris products that are on board payloads that we're flying as well. So we're putting all these down on a single stream onto the ground control station, and the PED management software is now managing all of that information.
How long has this project been in development from the time it first started to what we see today?
We first came to TNT in February '09. We came out with a concept demonstrator then. In the last year, in May, we're back out again with the system, and we proved out all the autonomous capabilities and payloads at the same time. And we're out here now just doing confirmation flights of the PED management system and other onboard payloads.
And the whole purpose of TNT is really to push the equipment to its limits and find out how far you can go and really fine-tune it before it gets to the warfighter.
Correct, yeah. It's an ideal opportunity for companies like us to come out here, because we can actually do a lot of things that in the testing environment here that normally on a military range you sometimes can't, and can be very expensive as well for a company to hire a range or hire time on the range. So here it allows us to interact with other companies. Of course, the warfighter, they can give us feedback on the systems and the approaches that we may be making that could be divergent to what they actually ultimately want.
What sets Ares apart from some of the other unmanned systems that we have? What's unique about this craft?
It's really its endurance and its payload, but it's also its mobility. We can load out on a single C-130 with multiple systems, set up a forward operating base like we've done here.
What are some of the biggest challenges that you face? Is it because of the size generally?
Well, a lot of the things is the technology that you have to implement for the size. You have to use advanced composites to keep the weight of the airframe down, and you need to be able to have an engine system and power plant that allows you to have a very low fuel burn rate and allows you to keep the endurance and at the same time lift all the weight. So those are some of the issues, and then it's a process that can take years and years just to get the aerodynamic properties right for the aircraft to be able to take off and land short without going out beyond 2,000 feet of runway space. Another key requirement for SOCOM and the warfighter was something that they could launch and recover on unimproved airstrips and etc.
Good. Well, good luck with your testing today.
Thank you very much. Pleasure.
Bruce, you're with Naval Special Warfare Command. Tell us a little bit about your job and what you hope to achieve out here at TNT.
I'm the Naval Special Warfare Command Science Advisor, and basically what that is we develop new technologies for the warfighter, for Naval Special Warfare, and what we're out here doing here with capability-based experimentation with SOCOM is working with companies and trying to see what the next generation technologies are that we can integrate or work towards integrating into our programs of record and into the hands of the warfighter. So what we're doing out here really is looking at technology discovery. So we're looking at what's in the laboratories that these companies have to offer and helping refine those designs and those capabilities so that we can do smoother transition into the warfighter's hands.
You mentioned a warfighter a number of times, and really that is what TNT is all about. It is really technology-based, getting it out here and pushing equipment to the limits to find out what they really need. And we know what they need, right?
Yes, yeah. I'm a retired SEAL, so I retired in 2007, so having coming up, with the current war and in Iraq and Afghanistan and stuff, bringing guys in that have been there, have done that, and getting them involved in the technology development really enhances the capabilities, and those guys know what they need. And that's really what it's all about, is getting in the hands of the guys who can use it and make a difference on the battlefield.
Stay with us for more on Inside NPS from Avon Park, Florida, here on the Pentagon Channel. Well, welcome back to more here on the Pentagon Channel on Inside NPS from Avon Park, Florida. We're out and doing some field experimentation, and with us is Mark Harris. Mark, tell us a little bit about your company and what your role out here in TNT is.
Well, we have a UAV system that I've merged my company with UA Vision, and Builders Development Group is an entity that we're trying to put together a disaster relief process that's going to revolutionize the way we track, do products, put them into a warfighter or a bad environment to where we can track and assess damages right from the get-go with RFID technologies.
Now this product that you have, it's behind us here, and we're going to take a closer look at it, but describe it for us and tell us how it was developed and what the capabilities are.
What we found was Don, the founder of UA Vision, he was a 20-year veteran in the Navy as a pilot. He come out, he is a current pilot for AFRL in Dayton at Wright-Patterson Air Force Base. He flies a lot of other people's planes, and he decided that it was time to develop something that was going to change the format of how people see it. Instead of search and destroy, search and rescue, and how could we come up with a plane that would do a lot of lot of information collecting and data right away without any hard takeoffs, landings. So we developed a plane that basically weighs less than 4 pounds, flies in high winds, up to 40-mile-an-hour winds, flies at high altitudes, has full data streams, and my company and his merged RFID technology into his aircraft. So we're doing reader writers from the plane, putting tags on the ground that can track and be a portal basically for information and data on the ground. Can take pulses off of a warfighter out in the field, tell where he's at, give a GPS coordinate, do all that kind of data stream right from an RFID tag. Surplus inventory control for disaster relief, drop off a pot of saline solution or something that may have a perishable date. Our tags are active. You can program them. You know what that perishable date is. You know what skid to open first when you're in a hostile environment, or if you're in Haiti in a disaster situation and you're trying to track this, along with developing a cloud with a 3G solar network that we can basically go out, drop off products, and now UN shows up, Red Cross shows up, SOCOM shows up, whoever shows up. Most of them don't talk between each other. They all have their own format, their own platform, their own supplies. Now we want to build a center of excellence in disaster relief surplus and supply, to where we tag all RFID supplies, and then when they show up, they download our app from the cloud. We can tell you if the UN's got 500 cases of water, the saline solution's over here, and everybody has a portal so they can work together.
So it really is a lot of what TNT in the field is a collaborative nature. So that's happened already, but you continue to collaborate with everybody that's here on this field training exercise.
What was interesting is when I met Dr. Bittner out at Camp Roberts here this last November, we participated in TNT. From that, we have experimented. We did over 96 ad hoc experiments with companies that we would have never met if it didn't happen for this event. And through that process, we were able, in between the times between TNT events, to collaborate, solve, put together the products, bring them back out here in the testing ground so everybody can see the wares of what actually happens at a TNT event.
And NPS has been a long time involved with disaster relief around the world, and as you mentioned, Ray Bittner, who we'll be talking to, is a great champion of testing this stuff in the field, and it's a great partnership with SOCOM. We really reach a lot of people, don't we?
Absolutely. Without this venue, you wouldn't have collaborations. I wouldn't have access to Boeing or Lockheed Martin or certain players that are just normally unaccessible from an entrepreneurial, for a small company to be in their venue. And so now we bring a technology that they weren't quite thinking of, and because they're a big spectrum player versus a small guy focused on something dramatic, they see the application. So we were able to contact into mesh networks, all types of things that we wouldn't normally have access to that technology. We know it exists, we know our technology will work with it, but now we get to test, play it, and work it. And it's really a great way of doing business.
Well, that's what happens with this field testing from Avon Park. Let's go flying. So Art, here at TNT, we're talking with different companies about technology and how it supports the warfighter, and I was caught in particular about yours. I wonder if you could explain a little bit to us.
Yeah, well, basically what Pictometry does one thing extremely well, and that is we shoot geo-referenced metric oblique imagery. That means we shoot at oblique angles instead of straight down. And once those images are taken, they're instantly geo-referenced, which means that we know where each pixel on that image is. We can measure on it and overlay GIS data and then create derivative products such as 3D models. So in this example, we have an oblique image. We're looking at the side of a building. We can understand the features of that building and see all sides of the building. We can see thin vertical features like light poles, where if you had a rotor hazard, that would be important. The GIS data then instantly can be overlaid on it, and then we can measure on that image. So we can measure length, width, area, and even heights. The unique thing about it is that because we know where in space each pixel on that image is, and because we're shooting multiple images in multiple directions, those images can be assembled mathematically into a 3D model. And then that 3D model, those same images can be draped on that model to create a photorealistic and photoaccurate 3D model. So in this example that we have of the city of Montgomery, Alabama, we're seeing a model that quite frankly looks so good, people thought it was just a video flyover, so I asked our technicians to uncover it to show that it's really a 3D model. And so we're seeing the model uncover here.
That's amazing.
And the thing that is important is that each building facade is not just a pretty picture or a clone or a texture. It's the actual image of the side of the building. and it's fully measurable and georeferenced. So for police work, for SWAT team, special operations, they can understand what they're dealing with, they can measure it, they can interact with this model in a 3D viewer and get a full, complete operational picture of what they're dealing with. If we don't have a good image of a side of a particular building, then we'll just leave it as a no data area. We don't fake anything at all. And that in a nutshell is what the pictometry technology is capable of doing. Fully georeferenced metric oblique imagery with the ability to overlay GIS data, the ability to measure in all directions, horizontal, area, and vertical, including an underlying elevation model.
Nice work.
Thank you.
Well, that's it for this edition of Inside the Naval Postgraduate School from the TNT in Avon Park, Florida. I'm your host, Alan Richmond, here on the Pentagon Channel. Thanks for joining us. We'll see you next time.